I'm Dave Anderson. You know, they have science camp, math camp, swimming camp, gymnastics camp. Why not economics camp, where young people can learn meaningful models about economics? That would be a dream. All right, ladies and gentlemen, today we can learn a new economic model. Yeah! Or we can go swimming. Boo! Let's review the Lorenz curve and the Gini coefficient, which are standard tools for the measurement of income inequality. The horizontal axis of the Lorenz curve graph measures the cumulative percentage of the population starting with the poorest and ending with the richest. So 20% indicates the poorest 20% of the population, 40% indicates the poorest 40% of the population, and so on. The vertical axis measures the cumulative percentage of income. So this point indicates that the poorest 20% of the population receives 5% of the income. And this point indicates that the poorest 60% of the population receives 25% of the income. The line of equality shows what the Lorenz curve would look like if each person earned the same income. In that case, for example, the poorest 20% would receive 20% of the income, and the poorest 60% would receive 60% of the income. The area between the line of equality and the actual Lorenz curve gets larger when income inequality grows. The Gini coefficient is a number that summarizes a country's level of income inequality. If we call the area between the line of equality and the Lorenz curve A, and the area between the Lorenz curve and the horizontal axis B, the Gini coefficient is A over A plus B. If there were perfect equality, A would be 0, and so would the Gini coefficient. If one person received all the income, the poorest 20%, 40%, 60%, and 80% would have no income, but the Lorenz curve would shoot up to 100% at the right end, showing that the poorest 100%, meaning all the population collectively, including the richest person, receives 100% of the income. What would the Gini coefficient be in that case? In that case, the area between the Lorenz curve and the horizontal axis that we called B would be 0, so the Gini coefficient, A over A plus B, would be equivalent to A over A, which is 1. For actual economies, the Lorenz curve lies somewhere in between the line of equality and the axes, which gives the Gini coefficient a value between 0 and 1. Here are some real-world examples of Gini coefficients. Wakeboarding camp? Circus camp? I'm going back to where I was. Pecan camp, pecan camp.
Way more fun than science camp!
Pecan camp, pecan camp.
It's the place to be!
Pecan camp, pecan camp.
Swimming camp gives me a cramp.
Pecan camp, pecan